So 4.5, not making the quiz, but the title of the section I think was equivalence relations. So to be an equivalence relation, there's 3 old properties from Algebra 1 they dusted off that have to be true for something to be an equivalence relation. Can somebody name me a name of one of these old properties from Algebra 1? Symmetric is one of them. S-Y-M-M-E-T-R-I-C is back. Other name of another property that these did make the quiz. So hopefully they just were written on a paper that I have on the file. Transitive is in this list.
Reflective.
That's close.
Reflexive.
Reflexive is in there. Can anybody give me an algebra sentence for any of those properties? Yeah.
Reflexive is A plus A equals A.
It's something close to that.
A equals A for every A.
And I'm good with just the A equals A part. The for any A part, you can say that, but I'm indifferent toward it. Indifferent's a fancy word that means I don't care either way. Symmetric or transitive? Can anybody do one of them?
Symmetric is AB plus BA equals something.
No, there's no adds in.
Just A.
Go ahead. Okay, it's if A equals B, then B equals A. Basically, it's something you've known for a while. If things are equal, you can reverse them. There's a word that's called symmetry. The human hand does not show you symmetry very well. The human face does probably show you symmetry. Why does my face show you symmetry, but my hand does not?
It's like the same.
It's like the same on both sides. So like, if you cut my face in half, I'd be a little upset. But the two halves would basically pretty close to mirror each other. Okay, my hand doesn't do that because my thumb is definitely not the same as my pinky. The way that my right ear is pretty much the same as my left ear. If I do two hands, now do we have symmetry? Yeah, because these pretty much mirror each other. But symmetry just means it's essentially reversible or mirrored. Reflexive, just A equals A. That seems too obvious to even be a property. It's just a thing. Transitive, we should know the best. Transitive is if... Correct. So they came along in the reading, and then the 7th point on the reading was there was something they told you that is an equivalence relation because these properties work. Anybody have a memory? What was the thing in the reading they said is an equivalence relation? And then they reworked these properties with other symbols. It works for equal to, but it worked for something else that they said. Anybody? No, will not work for less than. There's congruence of angles. Because is angle A congruent to angle A? Yeah. If angle A is congruent to angle B, would angle B be congruent to angle A? Yeah. If angle A is congruent to angle B is congruent to angle C, then angle A be congruent to angle C? Yeah. So I told you they listed the properties 2 ways. They did a list with the equal to's, which was fine. They did a list with the congruence and angle symbols, which is fine. I would do the equal list personally. It's a simpler list. But they told you in the reading you can do this with congruent angles just like you could do it with equal to. In terms of memory stuff, they helped you out here with the alphabet and counting. RST are number or letters that go in order. And then if you go 1 letter, 2 letter, 3 letter comparisons, RST, 1, 2, 3, that can help you do things. Transitive is a triple comparison. Symmetric is a double comparison. Reflexive is only a single comparison. So if RST 1, 2, 3 helps you memorize who's who, go for it. Question about life there? So then let's do something that I just shot down a second ago. Somebody said is less than an equivalence relation. I shot that down. I'll go greater than. So the basic structure of these properties, or these words, so if I try this out with greater than, If A is greater than B, and B is greater than C, think through that for a second. Would A have to be greater than C? Yes, transitive works. If A is greater than B, would B have to be greater than A? No, that's false. So we failed one of the tests that is not an equivalence relation. Greater than is not an equivalence relation. If we tested this out, is A more than A?
No.
No, that's false. That didn't work. Question about the idea of equivalence relation. Let's try one more. This symbol, what's that symbol called?
Greater than or equal to.
Greater than or equal to. Or is a good word. If your parents are ever giving you a list of words or a list of things to do, and they use the word or, you should be real happy, because what's that mean?
You only have a choice.
Do one of them, and they'll be happy. So if your parents are like, I want you to clean the room, clean your garage, do the dishes, take out the trash, and mow the grass, I'll be back in a day. You better do 5 things. If your parents say, I want you to do all this, or this, or this, or this, or this, and you pick your favorite and come home, you got a happy parent, right? The or is a friendly word for you. So if I say greater than or equal to, greater than can work, equal to can work, doesn't matter if it's one or the other. So would A always be greater or equal to A?
Yeah.
Yes, because it's always going to be equal. It won't be greater than itself, but it can be greater or equal. A will be always equal to A, so it's greater or equal. If A is greater or equal to B, would B have to be greater or equal to A?
Maybe.
Maybe. Maybe in geometry or life means
No.
no. Okay. Like if 4's more, if I do 4 and 3, that would make this true or false? This piece. 4, 3.
True.
True. 3, 4.
False.
False. If A is greater or equal to B, and then B is greater or equal to C, would A have to be greater or equal to C?
Yes.
Yes. So it made 2 of the 3 tests, but we still would say
No.
no. To be an equivalence relation, you have to pass all 3 tests. Question about what equivalence relation means, how to work these properties, something about that. Homework will do stuff like that, a little bit. Homework will do more stuff like this. They'll give you a sentence, here's 9 of them, and they'll ask you, is this reflexive, is this symmetric, or is this transitive, and they kind of disguise some of them. So I'll take opinions from anybody in the room. Everything up here is either reflexive or symmetric or transitive. Anybody have a feeling on what any of these are? First one is reflexive. If you only have one equal sign for comparison's sake, it has to be reflexive. If I went like this, it still would be reflexive. You know we can multiply in any order. I would still count that as the reflexive property. I didn't write it that way, so I'll return it to its natural state. But 1 is reflexive. Somebody else?
Is 2 symmetric?
2 is symmetric. If you have an if-then, and the things got traded, it doesn't matter if adding mixes in or doesn't mix in. We don't care about that. We have this symmetry there. If this, then this. Any symmetric property has to be an if blah, then blah. Then they need to get you a reversal. Somebody else. We'll get 9 people hopefully to play in my game.
Third one's also symmetric.
Third one is also symmetric. Again, to be symmetric, it's got to be if blah, then blah, and I need to get a reversal of the blahs. It's a double comparison, symmetric. 5 is reflexive. I agree with that. There's another single comparison. 5 is reflexive. Whose voice was that? Okay. So there's 4 people playing with me. 4 is transitive. Transitive is a triple comparison. If blah, and blah, then blah. We got to get 3 things going here. This A plus B shows up as a repeat. So then, since A plus B showed up as a repeat, that kind of joins together C and D. Transitive is going to be the star of this list. We're going to use transitive a good bit this year. Anytime there's a series of things that are equal, it's just going to be transitive. It might be like Liam has $10. Liam has the same amount of money as Asa. Asa has the same amount of money as Melissa. Melissa has the same amount of money as Caleb. How much money does Caleb have? $10. That's the transitive property. We linked all these people together. I talked about Liam twice and Asa twice and Melissa twice, and in the end it links together the original 10 with it. Somebody else play a game?
Reflective.
Where are you for reflexive?
So
6 is not reflexive.
6 is transitive.
6 is transitive. Transitive will always go if this and that, then this. And we have to get some repeats in there. So N is in here twice. And the N links together the M and the O for us. That's going to be transitive. Somebody else play with me?
7 is symmetric.
7 is symmetric. Symmetric always has to go if this, then this, and create a mirror. And swap the order that the things were in. 8 or 9?
Reflective.
8 is reflexive. If there's no ifs or thens, it's got to be reflexive. Okay. This equals itself. Why is this equal itself? I disguised it a little bit, but it's still a thing equals itself.
Because that's the same angle.
Yeah, it's the same angle. When we have a 3-letter name, we can just focus on the middle letter. Those are really the same thing. What's 9? Take anybody.
Reflective.
It is reflexive. Twice. That's reflexive, and then I did another reflexive. Stuff equals itself. Why can't that be symmetric or transitive?
No,
It doesn't.
Just yell. You're always raising your hand. Just yell out if you got it. You don't have to wait. Did you say Ace?
there's no then.
There's no then. We need a then. We also need
An if.
an if. So if it's if then, it's either symmetric or transitive. If there's no if then, it's got to be reflexive. If it's an if then where it just mirrored, that's symmetric. If you throw the word and in there, that's got to be a transitive. Question about that bar to life. So what we're doing off of that, there's a homework 98. So 98, 1, 2, 3 is doing this. 4 is still doing that. 5 is more like this. 6 is pretty easy also. 7, 8, 9 is where you're going to have some challenge on this page. So let's look at 99 and let me start to help you through this page 99 a little bit, part of this homework.
What page is it?
99. We're bordering on starting to do some proofs. Because we have the knowledge base to start to do that. And that's what this number 7 on 99, 8 and 9 is going to be a little bit of. Let me actually go first to the 101. Go first to 101, and we're going to take a look at the reading. And just so you don't get too paranoid, I'll show you how you do, if you know these words, you do actually have the capability to start to do some proofs. If you don't know the words, that's going to be somewhat challenging. That's why we need to make sure we learn the words. Okay, but off of 101, there's a theorem 4.2, says if the angles in a linear pair are congruent, each of them is a right angle. So someone remind me first, what is a proof? Logical convincing argument. So what we're going to try to do is just explain why this is a truth. So just take the sentence apart. If two angles form a linear pair, that should spark a memory thing out of you. Because we have a thing we should have been writing on the quiz now for about the 3rd or 4th day in a row that starts off, if two angles form a linear pair, blah. Okay, so if two angles form a linear pair, blah. What's up? What complete that sentence?
They're not, it's not congruent, so.
That's another word.
They're supplementary.
They're supplementary. Okay, so we know if two angles form a linear pair, then they're supplementary. What is that thing called?
Like the supplementary
That is the supplement postulate. Then we'll see if that sparks an idea. What do you know about supplementary? What does supplementary mean? If we add the measures, we get 180. What's congruent mean? That's in this sentence. Congruent means things have the same measure. So let's use our logic for a second. If two measures are the same and they add to 180, what would each of them be? 90. And if something measures 90 as a solo artist, what is an angle that measures 90 called?
Right.
A right angle. We just did our first proof. Okay. We had to know a bunch of words, and you could connect the dots, but only if you knew all of those words. Okay, if we didn't know one of those words, we'd get so far and be like, I don't know. Okay, but if two angles form a linear pair, then they're supplementary. Supplementary means they add the 180. They're congruent means they have the same measure. Logic dictates then the number for each was 90, and 90 means right angle. Replay. Okay, that's the kind of thing where we're trying to go. Okay. So what we just used there was the supplement postulate. The definition of supplementary is the thing that tells us we add the 180. The definition of right angle tells us that 90s are right angles. That's just sort of the things that we have. Somewhere I have a count. One of these lessons, I have people make a guess, and then I don't know where that is. Maybe that's not today. That's tomorrow. I'll just let that hang. Okay, but 7, in the homework for 7, what they're supplying is a bunch of statements, and you're trying to come up with a definition, or a postulate, or a property, or a theorem that makes this true. Okay, so 7a, they look at the picture and they say, yep, that is a linear pair, all right. Okay. If you see something like this, which I see that in the picture, I see one that's right side up, I see one that's upside down, I look at that, you look at that, we look at that. There are some linear pairs in that picture. Does anybody have a speculation on what definition, postulate, property, or theorem lets you look at something and go, seems like a linear pair to me? Theory? It is the definition of a linear pair. Very often, you don't want to overthink this stuff. If I start talking about right angles, I'm probably using the definition of right angle. Because do you have a right angle theorem? Do you have a right angle postulate? No. Do you have a property of right angles? No. So chances are it's going to be a heavy amount of definitions in this stuff. Sometimes it helps to throw in an if-then process. Geometry is a big if-then process. So I'm going to throw in an if-then, even though they didn't do it. I'll just sort of nudge you in this way. If in A they're talking about linear pairs, why in B are they justified in talking about being supplementary? What thing do you have that says if we have a linear pair in part A, then we must have supplementary angles in part B? That is the supplement postulate. Then let's build off of that. Supplementary, we just talked about a few minutes ago. What did supplementary mean? Measures add to 180. So if you look at C, you notice there's some measures, there's some adds, there's some 180s. What is up then with C? What fact do you think that is that justifies them talking about measures adding to 180 right after they talked about supplementary? No. More basic than that. They were just talking about supplementary, and now they're talking about measures adding to 180. Angle addition postulate not bad, because that has the measures adding, okay, but it doesn't have a 180 in it.
It's the angle of compression.
No? More basic than that.
Isn't that whenever stuff's like the thing where if they add up it equals 180?
No, more basic than that. I'm talking about supplementary, so then I start talking about measures adding to 180. That's just the definition of supplementary. That's all that is. It's the definition of supplementary lets us do that. Look at C. C's like some stuff that we just did in this column. Okay, so if I took C and I copied it into this column, what property does that look like if that's the if part? If the adding equals 180 and the adding equals 180 again, then in D the things equal each other, what property is D using based off of what C had? Stab at it?
Transitive.
It is transitive. Yeah, because it's like a triple comparison. The adding equaled 180, the other adding equaled 180. 180 is like the double thing, like I was underlining my things that were doubles in here, and that lets you link together a list. That's going to be transitive. Look at D, look at E. What happened? There was some stuff in D, there's some stuff still in E, but like, what happened as they jumped from D to E? Because that's what we're trying to figure out, is how did they jump? But first you have to notice, what did they even do? What did they do as they stepped from D to E?
They got rid of D and the.
Got rid of who?
D.
No.
They just simplified it. They got rid of measure of angle and UPC.
Yeah.
They're saying the same thing.
They are. D and E are saying the same thing. In D, they had a APC adding a BPC. They had a different thing also adding a BPC. So they decided to vanish the BPCs. So they're doing some kind of math here. So there was adding, and they were adding the same thing, and then they disappeared it. So what math thing lets you disappear adding? Subtracting. Do you have a subtracting property? Ever?
Isn't the SPE?
SPE, that's what that is. SPE is E. They did some subtracting to make that thing vanish. A couple minutes ago, when we had the two things making 180, we divided. That was the division property of equality. With the thing that I did that was our first proof talk of the year. I had two things that made 180, they each made 90. That was a DPE moment there. Then from E to F, if measures are equal, we would be justified in saying angles are congruent. Why are we justified if measures are equal to say that angles are congruent? What kind of a thing is that?
Just the definition of it.
Definition of what? Yeah, most things are definitions.
Definition
Definition
of
of congruent, what shapes?
Angles.
Angles. It's a definition of congruent angles. Later in the year, we'll have a definition of congruent triangles, we'll have a definition of congruent other stuff, but for now, we have a definition of congruent angles. That would have been a tremendous challenge if I didn't do that with you. So that's why I did that with you. Okay. 8 and 9, you're trying to do a similar thing by yourself. You're trying to read between the lines of how are they connecting from step A to step B, how did they make that jump? So there's a definition or a theorem or a postulate or a property, but the homework on 1 to 6 should flow pretty well because it's like this. 7 should flow pretty well because I just did them all. So if you can remember what I did, you're gold. Or if you wrote down what I did as I did it, you're even more gold, I suppose. Or if you didn't write it down, you can wait till the video goes up and grab it off the video later on, sometime today or tomorrow, I guess. But 8 and 9, you're trying to do a similar thing to what we did. And it's going to take some practice to get good at that. But step 1 is know the words. So if I say, if two angles form a linear pair, then what? And you go, I don't know. Well, that's not good. Okay, we need to know. If two angles form a linear pair, then they're supplementary. That's the supplement postulate. We need that in our brain. That's the thing we're going to use. If I start saying, this equals that, and this equals that, and this equals that, and this equals that, you need to start to feel out that that's what property. If I have this equaling that, and this equaling that, and this equaling that all over the place. That's transitive. If a bunch of things all equal each other, that's going to be a transitive property. Like, we need to start to feel those things out over time. But that's our situation for tomorrow. Quiz, quick description. You need to read 4.6. 4.6 is going to have a few theorems. We just read one of the theorems and proved it. Okay, that theorem 4.2. There's 2 of the theorems that have names. The 2 theorems with names, you'll need to say the sentence for them. There's 4 other theorems without names. You're going to need to fill in the blank on those. And you could fill in the blank either by learning them or by thinking them through. Okay, like the one we just did, if two angles in a linear pair are congruent, each of them we figured out would have to be if two angles in a linear pair are congruent, each would have to be a
Right angle.
right angle. We figured that out together. Okay, so the first four theorems, you could either figure them out on the spot in the quiz, or you could memorize the sentences if you want to. But we're going to fill in the blank, 4 theorems, and then you're going to have to say the 2 theorems that have names. Beyond that, the only change from today, the one angle question says name and define 3 angles. What are the names of the 3 angles? 3 angle types? Right,
obtuse, and acute.
and acute. So instead of me having that be 3 points worth of quiz where I spot you the names, it'll be a 6-point question where you'll say right, acute, obtuse, measure, 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 90, more than 90, less than 90.